Yo, what's up guys, this is my Minecraft operating system, and right now I am opening a file. Right now, each character of the file is being gradually loaded to the screen. We can see that everything is still intact from the last time I wrote to the file. I'm just going to be cleaning it up, just getting rid of the characters I typed in during my previous demos. But how is this possible? How am I opening a file on a Minecraft computer? Well, that's what I'm going to explain in this video. This is my Minecraft computer. I've showed it plenty of times before, but if you're new here, let me bring you up to speed. We got the big screen, the keyboard, the program memory, the big RAM, the registers, the math thing, the step counter, and then finally the inputs and the outputs. But all of this cool stuff is completely useless if there's no code for the computer to run. So let's check out how I coded my files. So this is the code for my file. Right now I just put it into a separate text file so I can edit this. Normally it is embedded into the operating system. But let's talk about how it works. You don't need to be a master at assembly to understand how this works. I made sure to label everything and I'll explain it in pretty good detail. But in case you know absolutely nothing about assembly, I just want to get a few things out of the way. First of all, it's that most of the stuff that happens in a CPU is moving data. It's moving data from one spot to another. And we call these move functions. And here's an example right here. The very first line of code is a move function, MOV. And it takes this value, R3, or this register name, it's just a register called R3, and moves it to a register called temporary. And that's really all you need to get from that. And if you were to look at the code, you'd see there's a lot of these move functions. There's also a lot of these LD functions, which stands for load. And this just takes an actual value, not just a register, but takes a value, data, specific data, and moves it into a register. So we can see here we're taking the value 6 and moving it into a register named function. And that's really most of the stuff you're going to see in this code. There are going to be a few more things that I'll make sure to point out, but that's really most of the stuff you need to know. But let's get started. So this very first part just gets the file name. As I've said in my last video, the screen is 8 characters per line, it's 8 by 8, so 8 lines, 8 characters, and I enter the code one line at a time. And so I found that I have 8 general purpose registers and there's 8 characters on the screen. So I'm like, hey, what if I just put each character in a correlating register? And then that way I don't need to access RAM or anything, and I can easily know where it is because I just figure out what position it was on the screen and I can access that register. So that's exactly what I did. So we are actually moving 2 of these registers. We have this R3, which is the F in F2, when I said FL, which is just file, and then space, and then F2, which is getting the name of my file. This R3 is the F, and then this R4 is the 2. And I'm just moving these 2 spots so I can manipulate them and do some math with them. Very first thing I do is I check if it's an F. If it isn't an F, it's going to say that's the wrong format, and it's going to just halt the program. This JIL is kind of a dumb name, but it's jump if load, and that is basically an if statement. So if a condition is true, it is going to jump to somewhere else in the program. So really just if this, then that. So assuming I had the correct format, it goes down here and converts my file number, in this example the 2, into binary. When I enter that 2 into the computer, it isn't actually a 2. It is the value 50, which is the ASCII value for 2. The character 2, not actually the number. So all I do is subtract 48 from it to convert it into 2, because 50 minus 48 is 2. Then there's this weird block of code here that shifts the number up 6 bits. And when I say up 6 bits, if you're actually looking at a binary number, it's actually to the left, and I'm making it larger. And when you're shifting bits by 2, it's kind of like with our normal number system. If I were to have a 10 and I were to shift it up or left 1 digit, it will go from 10 to 100, right? I'm just adding another 0 to the right of it. I'm just moving it over by 1. And so binary, it's very similar, but it doesn't actually multiply it by 10, it multiplies it by 2. So if I were to multiply it by 2 6 times, that's just 2 to the power of 6, that's 64. Now, if you guys think back, my screen is 8 characters by 8 characters. And so that means there's a total of 64 characters on the screen. And if each character is 1 byte, that means I need 64 bytes per file. And so by multiplying my file number by 64, I can make a chunk of 64 bytes. And so in that way I can make multiple unique files in my RAM. Then we run this function, call23. Now call just jumps to some other spot in the code, but saves the current step. So whatever line you're on, it saves that step, and then jumps to, in this case, line 23, not on here, in my actual operating system. It will jump there, run a function, run some lines of code, and then come back. And so in that way I can condense a lot of lines of code into a single line that's just a call function. So all this does is it clears the screen. And so before I start writing to the screen, I have to do a few more things. First, I have to save the value, so I save the very first index of the file. This is just the very first character, the address of the very first character. Then I create the last address of the file. I already made the address of the first character of the file. Now I'm making the address of the last character of the file. And because it's 64 bytes long, all I have to do is add 63. I'll explain why this is important in a bit. These lines are just simply setting it up, just prep for the operations, but do keep in mind this R2. So there's this grab character from file. All this does is it opens up RAM to the current file position to the current character and outputs that value. And then it gets the screen position, so this outputs R2, and this is where R2 comes into play. And this keeps track of where the character is on the screen. Then we save our file position, the position of our current file character, to R3, which is just temporary. We'll move it back eventually. And then we add 1 to R2. By adding 1 to the screen position, it will just move to the right. And if you're at the 8th character, the end of the line, it will just go to the next line. So that makes my screen very convenient. I don't need to do anything fancy. I just need to add 1 to my screen position. And after saving that back into R2, I run this, which checks if file position is over maximum. So this is where getting the last position of the file is very, very useful, because it will check if the current position is equal to the last position. And if it's equal to the last position, that means it's cycled through every single character of the file. And that will end this loop, break out of it, and move over here. But if it's not the end of the file, it will just loop back to line 46. And so this part here, actually 46 to 66, is actually a loop. It will loop many, many times, actually 64 to be exact. It will place every single character in the file on its correlating spot on the screen. Now for our final few lines of code, we just have our inputs and we have our resetting the operating system, and I'll explain all these. So first it takes the input. So here it reserves 2 registers, and it takes 2 values. And so these values are the character that you want to write and the position on the screen that you want to write it to, respectively. After you enter the character in the screen position, it then checks if you entered the escape key and the value for the escape key in ASCII, which is the value 27. If it is the value 27, it will jump to the part of the program that resets the operating system, and I'll show you that in a second. If it is not the escape key, then it moves on. So then here it just adds the file number times 64, which if we're talking about file 2, it's going to add 128. And so in this way it adjusts the screen position to the file position and opens RAM to that value. Then this writes to the file and the screen. So the RAM is now open. I enter my character into that spot of the file, basically rewriting it, writing over it, and then it outputs that character to the screen to see that I actually changed it. And then this line just jumps back to the beginning up here where I take my inputs again. And so then this way with the looping, I can enter as many characters as I want. I can modify the file for as long as I need to. Then this final part, this is what clears the screen and resets the operating system, getting ready for your next function. So if you do enter the value for the escape key, it will run this call23 again, which, as I said before, it is just a function that clears the entire screen, makes it blank. Then these 2 lines basically just reset the operating system. Then it jumps all the way back to the beginning, so I can start entering more functions. Now that I've talked about how this works, let's see this in action. So we have our function fl, and this is what the operating system takes, and it can see this and determine that it is a file function to open the file. And then I just have a space, there's nothing going on there, and then I have to enter the name of my files, either f1, f2, or f3. And we've just been doing f2, so let's continue with f2. Now for the final space. Now, the main issue with opening the file is that it takes a very long time. It has to do multiple steps for every single character on the screen, and there's 64 characters. Also, it accesses RAM that uses instant redstone, which is very fast, but is very glitchy. So when I speed it up, it actually brings down the speed of the game. Now that the file is loaded, let's modify it. So how about we just write the word nerd right in the middle, alright? Just something simple. So what I would do is I go to my keyboard and I would select a letter. So we would select my N right here, and we would enter that into the system, and so that's our first input. Our second input is the position. So maybe we move it 3 down, so this is kind of like an XY, so I'll break this up here. So we have 3 here for the Y coordinate, and 3 bits here for the X coordinate. So we want to go to maybe the third row, so we put in 3, and then I'll go to the second position, and then I enter that, and it should be loaded to the screen. There we go. Alright, so there's our N. I have to put this to 0 first, and then we can put in our second letter, which is an E. So I enter the E into the system. Same thing, I then select the coordinates, the same Y value, and we'll move it over 1 block. So we'll do 3, 3, and then we enter that, and it should be loaded to the screen. I'll clear this real quick. There's our E. And there we go. Not a very complex demo, but I hope it gave you guys the gist of how this all works. And you guys kind of know now that this isn't just magic that makes the words appear on the screen. There's a lot of math and computation behind it. If you guys have any questions, feel free to comment below, or my Discord's in the description, so you can ask me there. But that's all for now. Peace.